strange week last week. I know, congratulations. We're going to be doing a warm up today. That's going to be a little bit different than what you are kind of. It's going to be a little bit of getting you ready for today slash seeing what you wrote about graphing. So, you don't get it. Yeah, you, sorry. No, you get some. Actually, I was like, no, you get some. Don't worry. We'll make sure you get some. Thank you, guys. Because there's nobody there at 4th hour, so don't think about it for 5th hour. All right.
Right.
The goal of today's warm-up is, can you draw you're going to be drawing a quadratic with certain criteria. So your first one, remember, a quadratic is a parabola. So that's the U-shaped graph. And your only criteria is that it has to go through the point 0, 3. Okay? So now tell me, how do we graph the point 0, 3? Yeah, that means the x is 0, so I don't move left or right any, and I go up 3. So that's going to be your first point. And you need to draw any quadratic u that goes through that point. That's the only criteria, is that your u has to go through that point. That's the only thing it has to do. So how are you going to do that? I want to see how you draw this one. Make a U that goes through that one. It's a problem, not a line. So, not a line. U. It just has to go to that point. You don't have to worry about any other points. Okay. I like it. Okay. Nice. All right, don't borrow yours. Thank you. Nice. All right, Michael, can I borrow yours? Thank you. All right, guys, let's talk about this. So, how can you draw a U that goes through that point? Well, one of your classmates drew that. The vertex and the y-intercept are the same, but it goes through that point. Now, did all of you draw that exact same parabola? No. In fact, here is one. This is another classmate. This is how they do theirs. I'm going to connect the dots just so you can see it a little bit. So here's another way you can draw. Was there anything in those directions that said it had to point up or down?
No.
Nope. It just said it had to go through that point. Okay. So clearly, we cannot graph this. Not everybody drew the same graph. That's the goal. How do we get where we all can draw this exact same parabola? Okay, here's your second one. So in the second graph, you need to create a parabola, but this time it has to go through these intercepts. Okay, so you have to make it go through those two intercepts. I'm having a hard time seeing it.
I think it'd be better, yeah, if we did there. That's better.
Can you make a U that goes through those points?
Yeah, that's better.
Okay.
Yeah.
Awesome.
Giving it your all.
There you go. So yeah, there's yours. Now you're drawing your U that goes through it. So So you're creating a parabola or a U that goes through those 2 points. All you have to know, the only criteria is that it has to go through those 2 points.
One would be there, or would the other one be?
Nice, Ms. Lawyer. Thank you. Okay, I like it. Yeah, they're both about it. Okay. We don't know, like, that's the only thing that we don't know. All right, let's talk about what you guys came up with. So, again, you know it's a parabola, because I told you it's gotta be a parabola. One of your classmates drew it like this, pointed down, where the other did that. Notice they both went through those points, 3, 0, and 5, 0. Was there anything in the instructions that said that they had to point up or point down?
No.
Nope, it just has to go through those 2 points. So again, bummer, we do not have the same parabola. I'm trying to get to a place where we all draw the exact same parabola. All right, next one, next challenge. Here is our next challenge. Vertex. Your parabola must have a vertex that goes through the point 4, -1. And I will do that. Yours needs to go through 4, -1. What does that mean that the vertex is at 4, -1? Okay. Awesome.
My grade that.
You're good? Okay.
Yeah, my wife.
Now, what do we know about the vertex? The highest point. It's the highest point. Does it have to be the highest?
I told her that.
So I agree, because that means it's the highest point right there. That's 4, -1. The vertex is at the highest point. Could it have been the lowest point? Okay, could I have drawn it like this? And if we could have done either way. So there's a vertex. Notice 1 points up and 1 points down. Could go either way, right? There's nothing in the instructions that says it has to go up. We just know that the vertex, whether it's the max or the min, is at 4, -1. Okay. Last one. So far, we have not all drawn the exact same one. So here is what we need. You need the y-intercept at 0, 8. You need the x-intercepts at -2, 0, and 4, 0. And you need the vertex at 1, -9. Yeah, 0, 8. It's actually 0, -8, guys. 0, -8, -2, 0. See if you can grab all 4 of these. Which one? Vertex is 1, -9. 1, -9 is the vertex. Oh, what are the x-intercepts? Negative 2, 0. Okay, so you flip it over and you graph those points. Yep, that is correct.
Now connect those dots.
Yep, you're correct. And then the other one. Right there. Now just make your move.
That's right.
Type the corner. All right, guys. I want everybody to look at the parabola that I just drew on the board. I put in this X point. It's not what I gave you. It's just known as what's known as a symmetric point. You always have a mirror image of the y-intercept. So here's the y-intercept. There always has to be a point directly across, it's known as the symmetric point. Sometimes it just helps you to draw it. I didn't give that one to you, but I just put it in because it helped me draw it. Did any of you draw something different than what I have on the board? Is it exactly the same as mine? Does it go through all the points? Does everybody's point up? Okay, could anybody connect those dots where the vertex is here, but it goes the other direction? You can't, okay? So what that means is that you must have 1, 2, 3, 4 points. All of us need the exact same 4 points to ensure we all graph the same parabola. Okay, that is today's goal. Can you graph the same parabola as everyone else in the class? Okay, that's what we're trying to get to today. Hang on to this because it might come in handy. So, grab this guy. You should all have it should look like this. All right. So where are we? What is it we are doing here? Well, we are, you can believe it or not, we are at activity 822, which means we are really close to finishing chapter 8. And here is the first part. This is the question. What do you need to sketch a parabola? That is the first question. Now, we're trying to make it exact, okay? Meaning all of us make the exact same parabola. So let's look at this first one. Did we all make the same parabola when I gave you just the y-intercept?
No.
Guys, there's a lot of phone use going on right now. Put your phones away. What we're doing today is tough. In fact, you should never have your phones out in math. Okay?
So,
Yeah. You do not need your phones out. You just had lunch. You were able to do as many Snapchats as possible during lunch. Trust me, nothing exciting is going to happen between now and then with your friends. If they go to the bathroom, you can just let them go to the bathroom. You don't need to know about it.
right,
Even if they're vaping in there, you don't need to know about it.
absolutely.
All right. Can you sketch a parabola if you know what the y-intercept is? So that was our first question. We don't make the same one with the y-intercept.
No.
No. So let's sketch some differences. Well, we could have it look like this. Okay. There's our y-intercept. Some of us did that. Okay. Some of us made it exactly even like that. There's a whole lot of variety there. We can sketch it, but they're all different. Everyone graphs a different parabola. Everyone graphs differently. Okay. How about when we knew what the x-intercepts were? Did we all have the same parabola when we knew
No.
the x-intercepts? No, we did not know. So let's do some of those graphs. Well, let's try it. We knew we had, it looked look like this for some of you. There's your x-intercepts. But some of you made it go like that, right? Again, we can graph it, but we all graph differently. Graphs are different. Okay. We're trying to figure out what it's going to take. You guys know what it's going to take, but let's just process this. What does it take for all of us to graph the same parabola? Okay, this next one. Can you sketch with only its x and y? I didn't give you one with just its x and y, so let's try it. What happens if that's your x and that's your y? Okay, well, what if we did this? And here's some x and y's, but we did this. Are those the same parabolas?
No.
They're not.
One's
Well,
bigger.
these, technically they have the same x and y, so there's the x-intercept, there's the y-intercept, there's the y-intercept, those are the x-intercepts. But do I know how far down the vertex goes? No, that's why you need the vertex. You have to have the y-intercept, the x-intercept, and the vertex in order to do that. Oh, that's a lot of points. So again, graphs are different. You gotta have 4 points. Graphs are different. Now, if you were not here on Friday, what we did on Friday is we finished our water balloon exploration where we were launching a lot of water balloons and we're seeing where they landed. And we had this discussion about where is the line of symmetry. So where is the line of symmetry? What is the line of symmetry?
A line that goes right in the middle of the graph.
It is the line that goes right in the middle of the graph. I love it. I like the way you said that. Here's what Avery said. It goes right through the middle of the graph, but it goes through a very particular point. What point does it go through?
The vertex.
The vertex, and that's what you have to see. This is the line that cuts the graph in half, and it goes through that vertex. That's what the line of symmetry does. All parabolas have a line of symmetry. So the line of symmetry is the line that cuts the parabola in half and goes through the vertex. Okay, that's what it means. The line of symmetry cuts the parabola in half. But you got to know it goes through the vertex. That is going to be some really helpful information here in just a little bit. Okay?
That's a big equation.
All right. Well, this is where I think Algebra 1 gets tough, guys, because you now have to find all of these points. And so let me just give you kind of a heads up. Here's where we're headed. Remember, everyone in this room needs to be able to create the same parabola. So that means you have to, everybody has to know how to find the y-intercept, the 2 x-intercepts, and the vertex. Okay, you've got to put all these pieces together. All right, we're going to do this one at a time, but that's what we're trying to get to. Here we go. The key part about finding parabolas is being able to find all of the intercepts. Okay, I'm going to highlight that because I want you guys to understand like that's where we're going. You have to be able to find all the intercepts. So, how do you find the y-intercept? It's the very first graph that we did today in our warm-up. What's unique about the y-intercept?
There's no X.
There is no x. Well, the x is what?
0.
The x is 0, okay? So right here, the y-intercept is when x equals 0. Well, let's figure that out, okay? Let's plug that in. So here's what it's going to look like. Y equals 2, wherever I see an x, I'm going to plug in 0. Okay. All I'm doing saying, I want to know where the graph is when x is 0, because that's a nice point on the graph to be able to find. Tells us some stuff, okay? What happens? Yeah. Yes, absolutely. All right, what does happen when you plug in x is equal to 0? What do you get?
7.
Yeah, well,
Oh, negative.
yeah, negative 12. This becomes 0. 2 times 0 is 0. 5 times 0 is 0. 0 plus 0 is 0. Look at that. You're left with negative 12. But be careful. This is a point on the graph. Please put that as a point on the graph. It is 0, negative 12. You got to put that point there. If you don't, you're going to get yourself all flustered. Doesn't work out so well. Okay, that's the y-intercept. I love the y-intercept. The y-intercept is easy. You plug in 0, 0 multiplying by 0, adding zeros. Nice. Here's the question though. What happens if y is 0?
Oh, that's where the x-intercept is.
Yes, that's where the x-intercept is. So let's plug it in. What happens when y is 0? So I'm going to plug that in. Y is 0 equals 2x squared plus 5x minus 12. How do you solve for x? How do we solve
Get it
that
by
for x?
itself.
Okay, so that's exactly how you should probably think about starting it. Now, I don't want you guys to write this down. I just want you to watch. This is how we normally would start. I want to get my x's by itself. So I'm going to move my 12. And I get this.
Done.
What do you do?
Now what do we do?
Square root.
Okay, so my square root, I have this.
Ooh, never mind.
That looks hard.
But Spencer, I like the way you're reasoning through that because that means you're trying stuff. Sometimes in math, you just got to try stuff. That looks hard, right? That
Yeah.
is hard, Kellen, and I would not recommend doing it that way. You can, but it's confusing. Now, here is what I want you guys to think about. I'm going to take this part out. I don't want you to think about this part right now. I want you to think just about this part. What have you been doing to 2x squared plus 5x minus 12 for the past
The square
2
root.
weeks? You've been doing what with them? What are
Oh,
you
generic
finding?
rectangle.
Yeah, you're finding the rectangles using your generic rectangles.
Right, to the right.
Yes. So here's the beautiful thing about mathematics. That problem is hard. I will tell you, it took mathematicians centuries to figure out this problem. This was baffling, okay? But I want you to look, the thing about mathematics is if this is hard, can we transform this into something that makes sense in a different way? Remember, this is the area written as a sum. You guys can write the area written as a sum and as a what?
Product.
Let's do it. Let's see if that helps us, okay? I love it. Here we go. So this is what's known as the zero product property, and I'm going to talk about that. But for right now, I want you guys to do exactly what you all just said. Factor it. So let's factor it here. We have y equals 2x squared. This is the first day you've seen the y. We've now made this into a quadratic function. It's now an equation. But that doesn't mean we get to forget what we've been building to this. That's why we've been having you practice this thing called factoring because it's so important to solving this problem. Okay, when I build my box, what goes bottom left?
The square root. What?
The square.
The square, yeah.
The square. I got 2 purple pieces, so I have to say I got 2x squared here. What goes top right?
The
Negative
one,
12.
the unit.
Yeah, units, okay? Now, we know something very unique about this box. What do we know? What's unique about the box? What do we know about the diagonals?
Oh, that's
You had to multiply each other.
Gotta multiply. So when we multiply, what do we get?
Negative 26x squared.
Close.
Oh,
24.
So-
I messed up one.
The top of our box is 24x squared. So I know whatever 2 numbers I put here and here, whatever I put right here and here has to multiply to give me negative 24x squared. That That means I could put in 1 and 24, 2 and 12, 3 and 8, 4 and 6. Which one is it? How many oranges do I have to work with though?
Five.
I only have 5. Okay, this is where the puzzle begins. And see if you can figure it out. What multiplies to negative 24, but adds to 5. If you need help, we put those sheets on everybody's paper. What multiplies to negative 24 and adds to 5. See if you can figure that one out. You got it. Love it. What do you think?
No, you did that wrong. It's 2x. Times 3 is nothing.
So what do we get? And we don't have to graph it yet. It's okay if you do want to graph it, but we're going to. So be careful. You only have 5. It's just how it's done. So it's not 5 and 5. I know it's negative 5, but negative 5 times what? Minus 24. Well, we can hear which of those when you add in. What happens when you, which one of those when you add them or subtract them? So like if I, 3 and 8, so we know it'll be 3 and 8. Okay? Yeah. All right, guys, so you should be seeing that we have an
Guys,
8
off your phones, please.
and your negative 3, okay? 8 and negative 3. Because I know 8 times negative 3 gives me negative 24. 8 plus negative 3 gives me 5. So I put in my 3 and my 8, and now I just begin. Okay, common factor between 8 and 2, greatest one is 2. So I know my 2x comes here, and an x there. What goes right here?
Plus 4.
Plus 4, because I know 2x times 4 gives me 4x. What has to go here?
Negative 3.
Negative 3. Okay, so let's write that as its factors. My base is 2x minus 3. My height is x plus 4. Okay, I'm going to do a little squiggle there so I can keep going. Now we can find the x-intercepts. Okay? Now we can find those x-intercepts, guys, because I want you to think about something. Remember, the whole goal is to make y 0. And we're now multiplying 2 numbers together to equal 0. Okay, so we're trying to make, all we did was transform this into the area as a product. So the area as a product, I now know equals y, but I need that y to be 0. How do you get 0 when you multiply? You don't have to write this next part down, I just want you to see this. So what happens if I make this next part, what if I say I had, this was 2, what does that number have to be to make that 0?
0.
Has to be 0, okay? All right, so what happens if I said, okay, this one ended up to be, we'll say 5, what does that one have to be?
0.
0. 1. Only 1 has to be 0 to make the product 0. That's it, okay? So that's what we're going to use. We're going to use that idea of one of those has to be 0. So I want you, before I do this, I want you to think about this logically. Just look at this part right here. What would you put into x to make that whole thing in parentheses be 0? Okay.
-4. Oh, wait, oh, yeah, sorry.
So I heard 0. If you put in 0, you would get 0 plus 4 is 4. But I also heard I'd plug in 4. If I plugged in 4, what would I get?
8.
So what should I plug in? I need it to be 0. Lou, what do you think?
Negative 4.
Negative 4. Because what's negative 4 plus 4?
0.
I need what's in parentheses to be 0. Because I know one of them has to be 0. So here's what you're doing. Once you get your factors, you're going to take each factor and set it equal to 0. Okay? All right, let's set it equal to 0. What do I do to that negative 3? I got to get x by itself.
You add
I add them. Plus 3, plus 3. Okay, so then I get 2x plus 3. How do I, or 2x equals 3. How do I get rid of the 2?
you divide.
Divide. So I'm going to divide everything by 2, and I get x equals 3 halves. All right, now I have to do the same thing with this guy. X plus 4 has to be 0. But you guys already know that one. You already told me negative 4 is what I'm going to plug in there. Okay? All right, so let's plug in negative 4. Let's try it. I got to solve for x. I subtract 4 from both sides, and I get x equals negative 4. There it is. Now, whoa, what just happened? We're going to practice this a couple times. But what you have just found are your x-intercepts, and here's what it looks like. When x is 3 halves, y is 0. And when x is negative 4, y is 0. Both of those work. Let's try it. I'm going to plug negative 4 back into my original. So I'm going to plug negative 4 into that guy. You guys are in your friend. You guys are going to show me what it is. So I'm plugging in negative 4. Okay. In your calculators, put that whole equation in just as it is. Plug in your calculators and see what you get. Okay?
Put it in your calculators, guys.
See what you get. What should we get is the question. Plus. Yeah. Well, what do you know? All right, guys, here we go. When I hit enter on this, what should I get?
Negative 652.
I hope not. Oh my God, if I get negative 652, I'm just.
Oh, I didn't do the
blind.
plus. I didn't keep that.
What did you get, Leah? 0. Oh my gosh. When you plug in negative 4, y is 0. Now, if we plug in 3 halves or 1.5, plug in 1.5. Okay, 3 halves is just 1.5. See what you get. 2 times 1.5 plus 5 times 1.5 minus 12. Oh my gosh, if we hit enter and it doesn't equal 0, we are in trouble.
No, it equals 0.
And it equals 0. Whew. Thank goodness.
It's a good check.
That is a good check. Remember, we are looking for very specific points on our parabola, the points that make it easy to graph. What happens when y is 0? That's called the y-intercept. We're looking for when x is 0, that's the y-intercept. Then we're looking for what happens when y is 0. That's the x-intercept. You've got to have those points. Now, we have one more layer that we need, and that's the vertex. But we're going to graph one of these to get there. All right, turn your page over. And you are going to cross this guy out. we're not going to redo that one. I want you to write this. Y equals x squared minus 8x plus 15. And here's your challenge. Can you fill out the table and graph that? That's what you're going to be asked from now on, okay? Now, we're going to walk through the first one together, just so you can get a sense of like, oh my gosh, algebra just got really complicated. These are long problems, okay? Now, and then I'll let you guys try one on your own. Okay, I suggest going through the table in order. It just makes your life easier. So let's look at the y-intercept. Y-intercept. I got to find my y-intercept. How do I find the y-intercept? What is unique about the y-intercept? Yep, it's when what is 0?
Oh, X.
When x is 0, so let's plug that in. Y equals 0 squared minus 8 times 0 plus 15. Okay, what happens when you plug in 0 there?
Right.
What do you get? 15. Fantastic. Yeah, Cal, you get 15. But be careful, everyone. This is a coordinate point. I want you to write it as a coordinate point. It's when x equals 0. Okay? So we got to I'm always gonna make you write it like that. Write it as a coordinate point. When X is 0, Y is 15. Okay, and then I just fill in the table. It's a lot easier. Now, if I graph this, guys, 15 is not on my graph, so I kind of have to guess. So there's 0. I'm gonna go up to 15. I'm gonna say it's somewhere above the word solve. I'm just gonna take a wild guess. It's somewhere up there. We're not sure. All right, here's the hard part. Those x-intercepts. Ooh, x-intercepts. What do we have to do first in order to get the x-intercepts?
The square thing.
Yeah, we gotta do the square thing. We've got to factor. So I want you guys to factor this guy. Okay, let's make our generic rectangle. We have x squared and positive 15. So what multiplies to 15 and adds to what? Negative 8. Okay, see if you can factor that guy and get your base and height. Factor that. All right, how are we doing here? What multiplies to 15 but adds to negative 8? Yes. So which one has to be negative? Yeah, we gotta get to a positive. So what has that? Yep, very good. Okay, so what does multiply to 15 but adds to negative 8? Negative 3 and negative 5. Excellent. So I'm going to put negative 5, negative 3. It doesn't matter where the negative 5 and 3 go. Just put them anywhere. So I know that I have x squared. That's going to be x and x. What does my base have to be? X minus what? What is the, yeah, 5, because the greatest common factor between 5 and 15 is 5, which means this guy has to be 3. So when I factor this, I get x minus 5 as my base and x minus 3 as my height. Now, right here is where we see students not do so well, because they say, oh, my x-intercepts are negative 5 and negative 3. Whoa, wait a minute. That's not your x-intercepts. Those are your factors. We got to set these equal to 0. What can I plug in right here to make that part 0?
Positive 5.
What about that one?
+3.
There you go. So if you forget, just set each piece equal to 0 and then solve for it. That's all you're doing. Set each one equal to 0 and then solve. So we get x equals 5. And here we get x equals 3. Those are your x-intercepts. It's positive 5 and positive 3. Be aware of that because students often get that part incorrect on the graph. Okay, so let's put that in our table. One of our x-intercepts is 3, 0. The other one is 5, 0. Okay, once you have those 3 points, let's graph them. All right, 3, 0 is right here. 5, 0 is right there. What's the one thing we have left in our table that we got to find?
Vertex.
The vertex. Oh, that tricky vertex. Where will the vertex be?
In between.
Oh, it's halfway, right? What is halfway between those two?
4.
Okay, so we know that the vertex is at 4 something. So I'm going to come over here. I'm going to write my vertex. But here's the question. Is the vertex here? Oops, that's not 4. Woo. Is the vertex here? Is it here? Is it here? Is it here? Where? We know it's at 4, but it's at 4 what? How are we going to find that out? We know it's at 4, but how? What's the y coordinate going to be? How are we going to find that y coordinate? Do we just guess and hope for the best?
Yeah.
I'm going to guess it's 3, negative 3. Come on, lucky 3. What do you guys think? Think there's a mathematical way to do it?
Probably.
Okay, what do you guys think? Well, what should I do with this 4? What could I do with it? Well, this is x equals 4. Can we use that in that guy?
Oh.
Oh,
What would you do?
what would we do? What are we gonna do with that?
You just put it into the equation.
Put it into the equation. Okay, so let's put that into the equation and you guys can tell me where it is. So we're looking for when x is 4. Put this into your calculator, guys, and tell me what does y equal when x equals 4. If you get 10, you might want to check it because you got to figure out, oh, what is it? It's gonna, you want it at a nice place. Yes, there it is. Graph it and then see if you can finish the graph. Yeah. What happens? Oh, very good. Yes, so now we know the question mark. What's the question mark, guys? What is it? It's y equals what? -1. Excellent, Joanne. It is -1. So you get 16 minus 32 plus 15. Okay, it's a -1, so let's graph it. It's right there. And now we have our line of symmetry. We'll graph it here first. Wow, I just missed that vertex. That was fantastic. There we go. And our line of symmetry is a line. It's a vertical line that goes right through the point or the vertex. And remember, for those of you who are gone on Friday, a vertical line has the equation of x equals 4. It goes through that vertex. Okay. That's a lot of work, isn't it, guys? Just for one problem. Woo! All right, you have just about 8 minutes to see if you can finish the next one. See if you can work it on your own. Start with the y-intercept. Try to find those x-intercepts. See what you got on your own for this last guy.
You've got this.
I think you guys have it. Start nice and then work your way through. Just work your way through one at a time. It'll help you. Okay. So remember your x-intercept is when x is 0. Your y-intercept is when x is 0. So we split in 0. So it'll be 0 squared minus 2 times 0 minus 8. There you go. Now solve that and say, ooh, where are you on that? 4, 2.
We did something wrong.
I don't think so. I think you got it right. Be careful of the line of symmetry. Because it's x equals what? X equals -9 would be a vertical line going this way. X equals 4.
Okay, now I want to.
Okay, so you've got to set both of those equal to 0. If you can see it, you don't have to set it equal to 0, but remember, you're trying to make each one of those 0. Okay? There you go. So one of your x-intercepts is -2, the other one is 4. Oh, give it a shot. Maybe 4 and positive. What are you doing for your, there you go, -2, or 2x for x here. Well, we graph all of those points right now. Graph them first and then we'll talk about that vertex. Correct. I love it. Good. You're right there. Yeah. Yes. Yeah. Yes. So this means x is 0, but y is -8. That means you're going to the right 4, but not up or down any. So just write that 4 on that x-axis. Correct. Right. Right. So be careful here. you see how you're trying to get to negative 2? So you're trying to get to negative 2, which means the sign will switch for that one. Okay? Yeah, so switch your signs, because you should get your X to 4. Well, that's why I'm starting here. The y-intercept is X is 0. So plug in 0 everywhere you see X, then go from there. Alright, oh yeah, wait, no, you're right. You're right. And you just write it as negative 2x. Yep. So the x-intercepts, remember, are what it is, it's what number did you plug in right there? Well, you plug in, so be careful on this one, it's going to be a 4, because you're trying to get to negative, so it's x plus. You're trying to get to negative. Okay, so that'll be x plus 2. So now, think about what would I plug into my x to make that whole thing equal 0? Well, if I plug in 2, I get 2 plus 2, which is 4. But if I plug in negative 2, negative 2 plus 2 is 0. So that's why you put negative 2. What did you plug in right there? So be careful. So what minus 4 gives you 0? You got it right. It is 0. That means it's 4. Because think about it, 4 minus 4. Yep, and that's what we want. So it'll be 4, 0, and then this one is negative 2, 0. It'll look just like that. The x-intercept is what number you plug in. Yep, perfect. Now, graph these 3 points and we talk about how to find it. So it'll be 0, down. Okay, now we go 4, yep. And then 0. It'll be right there. Now, no, so to find the vertex, right? You know it's halfway between it's 1, but now there's already 1. Because you don't know how far down you're going to go. No, so we're going negative 2, we're going negative 7, you're negative 100. So plug in 1 right there. You know the vertex is halfway between. Yes, you can. Oh. Please, guys. Before you guys start talking up and get ready to go, let me show you. Yeah. Okay, let me just remind you guys. This week, you have 2 review previews, 822 and 823. Those are the last review previews for the year. Yeah, the year. Get them done. They close May 9th. Yes.
What's up? Nope, keep those, that will help you. All right, CBBI students, use these notes to complete your review previews for this week. You have 2 of them. We will be testing on Thursday. Remember, you want to get this information taken care of so you're prepared for the test on Thursday. Please reach out if you have any questions. We appreciate that you came here, and we are hopeful that everything looked okay and you are ready to roll for these review previews. Have a great Monday evening, and we will see you all tomorrow.
Yeah.